How's it going, Sierra? You ready for another video? You want to do another YouTube video? All right, let's do it. Hi everyone, welcome back to Dragonfly Engineering. So we've got a semi-live episode this week to talk about some new equipment that was acquired by Dragonfly Engineering for automating, hopefully, an in-house product that I'm planning on selling direct, probably on Amazon or something. And then we always have our security system here, Sierra. Say hi, Sierra. Okay, well, let me show you what I'm talking about. I'll take you back into the warehouse area. All right, so I got my nephew here, Simon, who has been in a couple of other episodes in the past. And move it around a little bit. And it may hit a hard stop, which isn't a big deal. But he's grown up a little bit since then, and he's turned into quite the computer hacker, actually. So say hi, Simon, to everyone.
Hi.
And so here is our new addition. This is a KURO robot that I bought by a local e-waste company who posted an ad for selling these robots. So this is similar to the other KURO robots that I use here at Dragonfly Engineering, and except that this is the new style of robot, where the other ones had more of a cylindrical shape. This is like the latest version of their robot. And this is a KR, what is it? I think it's a KR6R900. So this will pick up 6 kilograms, and it has a 900 millimeter reach. And then down here is the cabinet that came with this robot. So we'll kind of get a full view of it here. You can see, basically there is this powder coated solid steel box that the robot came bolted to, and it was packed with all sorts of accessories, like this barcode reader right here, and this touch screen computer interface, and also inside of the box, and it's running right now, so sorry about the fan noise, but we've got a Linux computer that has 2 graphics cards in it. You know, with that seem to be pretty powerful graphics cards, but we're not quite sure yet. And then down here is the KUKA compact controller. You can see KUKA there. But there's all sorts of other stuff in here. For instance, there's a network switch, and this is all basically created by whoever the e-waste guy got this robot system from. And we did a little sleuthing, but let me get back to what else is in here. So we've got a whole I/O module here, and usually the yellow and the red portions of an input-output module, which basically allows the computer or the KUKA robot controller to talk to the outside world with signals, like voltage signals. But I believe usually if on an I/O module, if the components are like red or yellow, that means it's safety related, like emergency stops and is the door to your robot work cell open or closed, etc., etc. And then down here is the regular input-output modules, which are similar to the Beckhoff output modules that I've shown how to configure with the KUKA robot controller, which is this one. So yeah, and I basically the deal was good enough where we wound up buying 5 of these robots, and they're all basically carbon copies of this system. So you can see the other 5 there, and we're gonna, like I said, we're gonna implement these into a robot assembly work cell in this area, this warehouse area, over the next several months or so. So anyway, Simon, would you like to describe your discoveries inside of this this robot controller?
All right, so basically this computer So there's actually 2 computers in this thing. So this is a
Okay.
big Linux computer,
Uh-huh.
and on top there's a tiny computer that's almost like a Raspberry Pi.
Oh, so just like a micro PC, but it's not PC, but a Linux computer in there as well. Right?
Yeah.
Okay.
So at first we actually thought that both these were one computer. We thought this box was like a converter from Ethernet to USB.
Yeah.
So yeah, it actually took us way too long to figure out that was not the case. But so
when you were trying to explore this system, you thought you were talking to this computer the whole time, but in reality you were just talking to this tiny little computer up here.
Yeah.
Oh, okay. Yeah, I can see how that could be confusing.
Yeah. So when we first opened up this computer, there was all sorts of safety net stuff. So and it was all super locked down, so we couldn't use any of the USB ports. We couldn't connect to the internet. We were not in like admin mode, so and there's all sorts of accounts on there. So basically what we had to do is we had to wipe the whole thing and install a new version of Linux on there.
Okay.
And
the accounts and the software that was on there, a lot of it was protected by passwords. But you were able to figure out basically who originally made this system?
Yeah.
And how did you do that?
Yeah, so we were able to see the list of the user accounts, and what we actually did is we went on LinkedIn and we looked up the people, and we saw that they're all Google employees. So we know for sure that this is a Google robot.
Oh, okay.
Yeah.
So basically he found the login, or the log, or just the list of logins?
Yeah, the list of login and,
okay.
and the name of the people logged in. So.
Oh, okay. And then we just saw on LinkedIn that they are all employees at Google, which makes sense because Google is close to where this shop is. So it looks like an e-waste guy basically bought these for whatever cost, and then he resold them to us. And then we found out that this whole thing and all the rest of these robots are from Google. And we're assuming that this system was like some sort of maybe recycling garbage picking instrument, because there is this vacuum sucker on the end here, a very expensive vacuum sucker, where like the vacuum sucker that I would make is just a vacuum rubber bellows at the end with a pneumatic valve, and the whole thing would cost like maybe $75. I think this thing, since it's got like its own little LCD screen and everything, is probably a little more than $75, but we have no idea. And the guy that we bought this robot and everything from is not a technical person at all. He's like basically like a recycler. So he didn't know that any of this information, and I don't know anything about it. So if any of the viewers are familiar with this like Ethernet enabled vacuum picker with its own like little touch screen on it, that I'd like to hear about it. Also, we have this, I think this is a force overload sensor. So if you hit the side of the end effector, which is what you stick on the end of a robot, too hard, then this silver disc with its own Ethernet connection will tell the robot to stop pushing, or basically it's a warning that you just crashed into something. And yeah, it came with like touch screens, and it's like a barcode reader. And then this is the new controller for the KURO robot itself. And we can look at this in a little more detail, maybe in a second. But one thing that Simon discovered was a really cool camera that was part of this system. It was just over here in like the gutted wire harness, because this module was pulled out of a larger system, and what we bought was just basically the wires that were strewn out from the original system as they pulled it from wherever. Well, we know they pulled it from Google, and they just like cut fiber optic cables and things like that. But we did find this interesting camera, which is over here. And this camera is like a stereo camera with a microphone, but it also has a LiDAR sensor. And a LiDAR sensor is used for measuring distance and mapping structures in front of it into a 3D map. So Simon was able to find the driver. You look up the name of this camera, and it was an Intel?
Yeah, it was an Intel RealSense camera.
Intel RealSense camera.
D400.
Oh, okay.
Yeah,
D400?
Yeah.
And it looks like it's made for robot systems, like AI. I'll throw out the AI term since that's hot right now.
Yeah, so it was plugged in actually into the beefy Linux computer, so we think it did some sort of computer vision, like AI processing stuff.
Oh, okay.
So
yeah, so and then you also found that these two video cards are Intel video cards.
no.
Oh, they're not. Oh, we're not sure yet. Okay. But anyway, this is the feed from the camera itself. So you can see, you know, a regular kind of video stream of me looking at the monitor. But over here is a real-time distance measurement. So, for instance, Simon is closer to the camera, which is on the saw, than I am. So you can see how he's like a lighter color, and I'm further back, and then the robot's even more further back, which is the darkest. And then on the side, there's actually a scale in meters. So Simon is about, you know, 1.7 meters away, and I'm about 2 meters away, and the robot is about 3 meters away from that camera. And then other cool things is that it'll do like a 3D real-time render of your workspace. So now you can see that, you know, we're basically standing in this work area with the robot behind us. And you can see that same setup, and Simon can actually rotate our 3D like shapes with our faces applied to it, or do a distance measurement like that. And it'll show in real time, like, you know, like I'm moving my hand in and out, and it's measuring like where my hand is relative to the camera. So why don't you bring us back to that other 3D view, or I guess where we paint the video signal on top of our positional data. So there you can see us, and now he's rotating us around in this virtual workspace. And it'll actually show the back of our head, you know, because the camera can't look around us, but it can basically map what it can see, or what the lasers are scanning from the LiDAR laser that's inside of that camera. So right now there's like a high-speed laser that's scanning everything in front of it, and it's seeing how long it takes the light to bounce back to the camera, and then it's calculating where we are in this 3D space. And it's real time. So why don't you rotate it around some more? Okay. But like I mentioned, you can't see the back of us, so it'll just kind of show like a shell, like a half shell of us, and then you can see me from the inside, and then it'll spin it around. So this is pretty neat. And I think we can use that fancy camera with this robot to do vision calculations and actually pick parts ourselves, which is, I'm sure, what this robot is used for. And it'll also give actual positional data as well. Was that in the 2D mode?
Yeah, and also in 3D mode too. So if you put your cursor, or let me do it on this. Actually, this is easier. So if you put your cursor over the person, you can see.
Okay, there we are.
You can see coordinates and also the meters.
So that's saying where we're at relative to the center line of our camera, which is over on that saw.
So the robot is 2.7 meters away from the camera.
Yeah, and I think that's about right. So this is just about 2.7 meters, or like 8 feet away, give or take. I'm sure there's calibrations and things that you do. But we found this pretty neat to be able to see our real-time 3D render with our faces painted on top of it in a 3-dimensional workspace. So yeah, anyway, cool. All right, I'm gonna stop. Yeah. All right. Okay, so here's the new KURO controller as well. The previous ones were more of an orange color with more of a bouncy surround on it, like an impact-resistant rubber. And this still has it. There's some rubber on the corners, but they just changed the style. But it seems like it works basically the same as the other, or the previous KURO controller. So one thing I had to do was I had to basically reset this robot to the original KURO factory settings with, it's called the base project. And because when I turned it on, all of the previous company, i.e. Google's infrastructure, was all wired in, so the robot wouldn't do anything because it was expecting to see its whole world of interconnection, and it didn't. So I basically wiped it back to the original factory settings just to make sure that the robot works. And it does, fortunately. So we're in world mode, so you can move axes individually on the robot in axis mode, or in world mode we've got X, Y, Z, A, B, and C, and A, B, and C are the the three angular orientations of the end effector. So I'm gonna turn on the drives for the robot. This is in teach mode by hitting the old panic bar, and you can see our axes turn green, and then we'll see how our robot works. And it actually does work, you know, because this was a used purchase, as is, where is, and all that. And I did take a little bit of risk that I couldn't turn these on at this e-waste warehouse. But I saw, for instance, like the robot controller still had the original Mylar film on it. So I was pretty sure that these actually did work. And they do. So you can see how the end effector is tracking, it's keeping its angle square, which is also a good sign that the robot is calibrated correctly. So this suction cup won't change angles at all, except for if I tell it to change an angle. I gotta turn on the panic button. You know, we can spin the end effector around the A axis, or we can spin it around the B axis, and it's rotating probably at the flange of the robot arm itself. And of course we can move up and down and in and out and all that stuff. So that was good to see. Oh, it hit a limit. Oh, hit the limit again. Let's try this way. Yeah, it can reach out 9 meters. And the nice thing is this huge solid steel box is enough of a foundation and a counterweight where the robot is happy moving pretty quickly. So I was relieved to see that this thing actually works. Okay, a little bit more about this I/O module. As I mentioned, this is kind of a key component for our system to talk to the outside world, like to other robots or other equipment, or just turn on grippers and things. So the way that we see this configuration that came from Google is that everything's running off of Ethernet connections, which are these cables here, and there's an Ethernet switch that all of the communications for all the peripheries are going through. And what we need to decide is, do we configure the KURO robot controller to interface the I/O module directly so that we don't need another computer in the mix or in the fray to basically control the robot, or if we're going to wind up using our crazy vision system with that camera, then it may make more sense to actually use the Linux computer as the main brain for everything, including the I/O module interfacing with the Linux computer, and the Linux computer would then give commands to the KURO robot to do more simple activities, less algorithmic, but just move here and then wait for the Linux to figure out what to do next with the use of the vision camera or whatever this I/O module signals are telling the Linux to do. So that's where we're at the moment. We're trying to decide, do we need that super fancy camera, or should we keep it simple and just have the KURO talk directly to this I/O module, which I'll probably put its name up on the screen, because I'd have to dig in there and figure out what its name is at the moment. So if anyone has comments, I'd love to hear about it in the comment section. Or if you worked on this system and you're allowed to say anything about it, I'd love to talk to you as well. He may have covered this as a folk song.